While discussing range, we had listed some desirable properties that a measure of dispersion should have. If all the values are the same, then the dispersion should be 0. The next property is, if all the values are shifted together, then the dispersion should not change. The third property, if the data values change unit, that is, they all get multiplied by the same number, then so should the dispersion except for the sign. Now let's see if variance and standard deviation have these qualities. Here it is enough to work with variance because standard deviation is just its square root. Now don't worry about the n that I am using in the denominator. The results will remain the same even if you put n minus 1 there. If all the data points are the same, then all the xi's are the same and then x bar will also be that same number. So all these xi minus x bars will be zeros and hence the variance is 0. So the standard deviation is also 0. If all the data points are shifted by a common amount, then this x bar also gets shifted by the same amount. So xi minus x bar remains unchanged. So variance as well as standard deviation remains unchanged. If, however, all the values are multiplied by a constant, then each xi's are multiplied by that constant. So x bar also gets multiplied by the same constant. That constant comes out of the bracket and completely out, but because of this square, that constant will become square of the constant. As a result, variance will be multiplied by the square of the same constant. That's not very desirable. However, standard deviation has the right behavior. In fact, that is the reason why we care about standard deviation. It has the same unit as the data, while variance has the square unit like area. Okay, so we have checked the good properties. Now let's check robustness. We have already mentioned that variance and standard deviation are more robust than range. But you know what? Even these are not sometimes robust enough for some purposes. So stay tuned for something more robust in the next video.